Hello and welcome. In this video, we'll explore the ReLU activation function, what it looks like, how it works, and why it's so important in training deep neural networks. In video 15, we learned that earlier activation functions like sigmoid and tanh cause vanishing gradient problem in deep networks, making training slow or even stopping it. So, to resolve vanishing gradient problem, ReLU was introduced. Rectified linear unit, called as ReLU, is a more modern and widely used activation function. It is also called father of all activation functions, means to achieve maximum accuracy and efficiency. ReLU is preferred over other activation functions. It is a nonlinear activation function, allowing neural networks to learn complex patterns and making backpropagation more efficient. Its range is, meaning the function only outputs non-negative values. Mathematically, it can be represented as. This means ReLU outputs the input value if it is positive or 0, and returns 0 for any negative input, making it both simple and efficient for computation in neural network. The graph shows that for any input value of x that is greater than or equal to 0, the output is equal to x, resulting in a straight line with a slope of 1. However, for input values less than 0, the output is 0, which creates a flat line along the x-axis. Due to this reason, during the backward pass, the weights and biases for some neurons are not updated. This can create dead neurons which never get activated. As the graph shows, ReLU passes only the positive part of the signal forward, effectively turning off neurons for all negative input. As shown both mathematically and graphically, ReLU operates on the weighted input. That is, the input obtained by multiplying the input value with the weight and adding the bias. Now, observe this animation. ReLU outputs the positive values as they are and gives 0 for any negative input. If we talk about strengths of ReLU, we can say that it offers several strengths that make it ideal for deep learning models. First, its simplicity lies in the fact that it only involves a straightforward rule, outputting 0 for negative inputs and the input itself for positive value. Second, it is computationally efficient because it avoids complex mathematical functions and activates only neurons with positive values, while neurons with negative outputs are set to 0 and effectively ignored, reducing the computational load. Third, ReLU helps mitigate the vanishing gradient problem by allowing gradients to pass through unchanged for positive inputs, which helps in training deeper networks. Lastly, due to these advantages, it enables faster training, accelerating the convergence of neural networks. That wraps up today's video. Please don't forget to subscribe our channel, like the video, share, and comment it to stay updated with this series.